Hi everyone, my name is Amitesh, and in this video we're going to do the Pythagorean theorem within 10 minutes. We're going to talk about what it is, how we can apply it in day-to-day life to real-world problems, and also how to prove it mathematically. So let's just dive right into it. What is a Pythagorean theorem? It's a fundamental law concerning right triangles. So a right triangle is a triangle, it has three sides, and you have a right angle here, okay? And what you can do is the Pythagorean theorem tells you that if the length of the third side, called the hypotenuse, the longest side, is C, and if the lengths of the other two sides are A and B respectively, it gives us a beautiful relationship between C and A and B, and the relationship is that C squared is equal to A squared plus B squared. It does not matter what A, B, and C are as long as we have that right triangle over there. So before we talk more about the Pythagorean theorem, let's talk about a beautiful real-world problem that comes up all the time, is when we want to go from one point to another in the fastest possible way. So for example, suppose we have a field, and suppose you are at home, okay, so here you are at home, and you want to go to a bakery, for example, in the morning, and it's at the other corner of the field. So the fastest way to do that, you would tell me, is to go straight diagonally across, and I'm going to use a red pen here. You want to go straight diagonally to cut across the field rather than taking the other route, which is to go parallel to the base and then parallel to the height. That would be a slower route. But the Pythagorean theorem allows you to actually determine the distance directly with this beautiful formula if you know the dimensions of the field. So for example, if you know that the dimensions of the field are A and B, then you can work out the distance C you have to travel using the Pythagorean theorem. You know that you have a right triangle here because it is a rectangular field, so every angle in a rectangle is a right angle, and you know that C squared is equal to A squared plus B squared. So therefore, if you want to solve for C, you know what the square of C is, so C should be the square root of its square, so it's going to be the square root of A squared plus B squared. So that is a formula for finding distances, and it theoretically works in many different situations. So there are many real-world situations you can find distances in this way whenever you see a right triangle. Now, what are some examples of concrete right triangles satisfying this law? So some beautiful examples are the following. So I'm going to erase this rectangular field. Suppose I have a right triangle where this side length is 3 and this side length is 4. Pythagorean theorem tells you what the side length of the hypotenuse is, just from scratch. Because let's say we don't know what it is, let's call it C, we don't know what C is. What we can do is we can use the Pythagorean theorem to say that C squared is equal to 3 squared plus 4 squared. And now we know that C squared is 3 squared plus 4 squared, which is going to be 9 plus 16, which is going to be 25. What positive number squares to be 25? It's a square root of 25, which is 5. So therefore we know that C is going to equal to the square root of 25, which is equal to 5. So we have figured out that the hypotenuse has length 5. Here's another example of a problem that comes up where you can also use the Pythagorean theorem. So suppose I have a right triangle like this, and suppose that I know the length of the hypotenuse and one of the sides. Okay, so suppose I know the hypotenuse has length 10 and another side has length 6, and I want to figure out what x is, where x is the side length of that vertical side. We can also use the Pythagorean theorem because it's a law that relates the three side lengths. So if we know two of them, we can always find out the third, and I encourage you to pause the video and actually do that for yourself and drop a comment down below how you would actually do it. But let's do it now. So what we can do is we can say that the Pythagorean theorem tells us that 6 squared plus x squared is equal to 10 squared. Okay, so I've just written it out in the equation I've written out in the other way. C squared is A squared plus B squared, or A squared plus B squared is C squared. And now, always to solve an equation, you isolate the x. So we know that x squared is going to equal to 10 squared minus 6 squared, 100 minus 36, which is 64. So we've worked out the side length of the third side, knowing the hypotenuse and one of the other sides. So this is the power of the Pythagorean theorem. It gives you this law, and I encourage you to find, sometimes the answers aren't quite nice. So mathematicians, I think in ancient Greece, they're the ones who discovered the Pythagorean theorem. They also saw things like interesting numbers come up when you study triangles. For example, you might study a triangle with side length 1. It's very natural. 1 is a simple number. So you've got 1 and 1 there, and you might ask, what is the length of the hypotenuse? And you get some interesting numbers in this way. For example, here, if the hypotenuse is called c, then what you can do is you can say c squared is equal to 1 squared plus 1 squared, which is equal to 2. So therefore, c is equal to the square root of 2. So you get numbers like the square root of 2, which, even if you weren't interested in that, it comes up naturally in geometry. And, if I have to walk 1 mile in one direction and 1 mile in the perpendicular direction, what is the length of the shortest path that goes to my destination? That would be root 2 miles. So that's a beautiful example of the Pythagorean theorem. It's a beautiful proof. It's discovered by the ancient Greeks, and it's just a picture. It's a marvelous picture that just shows you why the theorem is true. And if you think about it, the fact that there is such a beautiful law is something that is enshrined in nature. Just like we see plants and trees and mountains. The same way, this is a beautiful fact that is true whenever you have a right triangle. It's enshrined in nature, and although it's something we take for granted in math, how do you even expect that such a simple law is actually true? But let's actually get into the proof, and the proof is just a picture. So the proof is, we're going to draw the following picture. So we're going to draw a square, and it's going to be a square of side length a plus b, okay, where a and b are these numbers here, but we'll get into it. So what we're going to do is we're going to draw a square. We're going to imagine each side length has length a plus b. So we're going to have a, b, and we're going to keep going. We're going to have a, b, and we're going to have a here and also b here. Okay, so I've drawn a square where the side length is a plus b, and what we can do is we can draw a square inside this square, and that will basically be the proof of the Pythagorean theorem, which is really cool. So the square is going to look like the following. We're going to put this length here. We're going to then put this here, then we're then going to put this here, and we're then going to put this here. Okay, now my square isn't a perfect square, but you sort of get the idea. The point is that first of all, in the original square, you're going to have all right angles, right? You're going to have all right angles because that's what the angles of a square are. And because of that, you know that whatever this triangle is, right? We're trying to figure out what C is. Whatever C is, we know that C is appearing as the side length of every red line in this picture. Okay, so you can say that each red line, this is going to be length C, this is length C, this is length C, this is length C, because it is literally the right triangle with lengths A and B that is rotated. Okay, so it's the same triangle rotated and repeated 4 times. So all these lengths are going to be C, so this is also going to be a square. And now the proof of the Pythagorean theorem is based on the question, what is the area of the big square? So the area of the big square, well, the area of a square is the square of its side length, right? So the area of a square, I'm going to write this, area of the square of side length C, okay, side length C, is going to equal to C squared. Okay, that's number 1. The area of the square of side length A plus B is going to equal to A plus B squared. Okay, so that's the big square. We'll have area A plus B squared, and now we can figure out, well, what's the area of the big square going to be if we split it up into its smaller pieces? You have on the one hand this little square, and on the other hand you have each of these triangles. So what is the area of each of these triangles? I want you to figure that out. Pause the video, think about that, drop a comment down below. Now that you've done that, we're going to get into it. So the area of each triangle, so there are 4 triangles, area of each triangle is going to equal to, well, the area of a triangle is half times base times height, right? If you have a triangle that has length like this, where the base is A and the height is B, or whatever it is, well, the area is going to equal to half times A times B. So therefore, we've got all that. Now we can figure out that the area of the whole square is the sum of the areas of the smaller square and the 4 triangles. So therefore you get A plus B squared. So I'm going to write this in red. A plus B squared is going to equal to C squared plus 4 times half AB, because each triangle has area half AB. So 4 times half AB, so 4 times half AB, which is just going to equal to C squared plus 2AB. Okay, so C squared plus 2AB. Now we use the binomial theorem. Okay, so the binomial theorem, when I've done a video on it. If it's uploaded at the time you're watching, links will be down below in the description. But it's a famous theorem. It basically says that a plus b squared is a squared plus 2ab plus b squared. So therefore, we know that a squared plus 2ab plus b squared is equal to c squared, which therefore means that c squared plus 2ab, which therefore means that a squared plus b squared is going to equal to c squared once we cancel off the 2ab's from both sides. And that is the Pythagorean theorem, a squared plus b squared equals c squared. It's a beautiful proof based on this picture. Whoever came up with it, it's a beautiful argument, very creative. It shows you what math is all about. You know, math is not about memorizing these formulas. It's about these kinds of pictures, creatively thinking about things and understanding things. You show someone this picture, they can find the proof. You know, that's what math is all about. So thank you so much for watching. I hope this video gave you a quick overview of the Pythagorean theorem in a nutshell, all in 10 minutes. I might have shot a little bit above 10 minutes, but roughly 10 minutes. And please subscribe, leave a like, check out other content on my channel. My goal is to create free accessible math education worldwide so everyone can love, enjoy, and benefit from math. That's my goal. And by supporting my channel, by subscribing, liking, and watching, you're helping me achieve the goal of helping as many people as possible. So thank you so much. I wish you all the best, and I'm super excited to see you soon.